When a submersible pump is experiencing thermal overload issues, several factors could be at play. The first troubleshooting step involves checking for voltage drop. Inadequate voltage at the pump terminals can lead to an increase in current draw, causing the thermal units to trip. Ensure the voltage supply is stable and within the specified range for the 460 volts, 3-phase, 60 Hz pump. Secondly, inspect the impeller and mechanical seals. Debris or damage to these components can increase friction, subsequently raising the current draw. Clear any obstructions and replace damaged parts as needed. Thirdly, verify the pump tolerances. Confirm the pump is correctly sized for the application and operates within its design parameters. An undersized pump or one operating outside its intended use can draw excessive current. Fourthly, test the capacitors if the pump has them. Malfunctioning capacitors can cause increased current draw and lead to thermal overload. Replace any faulty capacitors. Fifthly, inspect the contactor contacts within the starter. Look for signs of arcing or pitting, which may indicate a high resistance fault. Clean or replace the contactor if necessary. Now, regarding thermal unit selection, it is crucial to understand that increasing the size of the thermal units without careful consideration of the pump's operating parameters is not advisable. Oversizing the thermal units can create increased safety risks and potentially damage the pump. The thermal unit should be selected based on the pump's specific load profile and operating temperature. Instead of simply increasing the thermal unit size, it's recommended to take the following actions. Firstly, contact the pump manufacturer for guidance on the proper sizing and selection of thermal units. They can provide specific recommendations based on the pump model and application. Secondly, have a qualified electrician thoroughly inspect the electrical system and the pump to identify any potential issues that may be contributing to the overload. Thirdly, consider installing a motor protection relay. This device can monitor current, temperature, and other critical variables to protect the pump from damage. Fourthly, regularly monitor the pump's operating parameters, including temperature, current draw, and vibration, to ensure it is operating within safe limits. Using a motor protection relay is advantageous because it provides comprehensive monitoring and protection for the pump. These relays can detect various fault conditions such as overcurrent, undercurrent, voltage imbalance, and overheating, and can automatically trip the starter to prevent damage. This advanced protection can significantly extend the life of the pump and reduce downtime. Selecting the correct thermal units is critical for protecting the motor from overloads. The thermal units are designed to trip the starter when the motor current exceeds a predetermined level for a certain period. This protects the motor windings from overheating, which can lead to insulation breakdown and motor failure. When selecting thermal units, the pump's full load amps rating should be used as the primary basis for selection. Consult the starter manufacturer's literature for specific thermal unit selection tables. These tables provide the appropriate thermal unit size based on the motor's full load amps. It is also important to consider the pump's service factor. The service factor is a multiplier that indicates the motor's ability to handle occasional overloads. If the pump has a service factor greater than 1.0, the thermal unit size can be adjusted accordingly. However, it is generally recommended to err on the side of caution and select a thermal unit that is slightly smaller rather than larger than the calculated value. This ensures that the motor is adequately protected from overloads. If the existing thermal units are tripping consistently, it may indicate an issue with the pump itself or the electrical system. Before replacing the thermal units, it is important to thoroughly investigate the cause of the overload. This may involve measuring the motor current under various operating conditions, checking the voltage at the motor terminals, and inspecting the pump for mechanical problems. If the motor current is consistently higher than the rated full load amps, it may indicate that the pump is overloaded or that there is a problem with the motor windings. In this case, it is necessary to address the underlying issue rather than simply increasing the size of the thermal units. It's also important to consider the ambient temperature when selecting thermal units. The thermal units are sensitive to temperature, and their tripping characteristics can vary depending on ambient temperature. If the pump is located in a hot environment, it may be necessary to select thermal units with a lower tripping current to compensate for the higher ambient temperature. In addition to selecting the correct thermal units, it is also important to properly install and maintain the motor starter. The starter should be installed in a clean, dry location and should be protected from moisture and dust. The starter contacts should be inspected regularly for wear and corrosion. If the contacts are worn or corroded, they should be replaced to ensure reliable operation. It is also important to ensure that the starter is properly grounded. A good ground connection is essential for protecting the motor and the electrical system from faults. The ground connection should be checked regularly to ensure that it is secure and that there is no corrosion. When troubleshooting motor overload problems, it is important to follow a systematic approach. Start by gathering information about the problem, such as when the overload occurs, how often it occurs, and what the operating conditions are at the time of the overload. Then, use this information to develop a list of possible causes. Once you have a list of possible causes, start testing and inspecting the various components of the system to eliminate potential problems. Be sure to document all of your findings so that you can track your progress and identify any patterns. If you are unable to resolve the problem yourself, consult with a qualified electrician or motor service technician. They will have the expertise and equipment necessary to diagnose and repair the problem. Remember, electrical work can be dangerous. Always take the proper safety precautions when working with electrical equipment. Wear appropriate personal protective equipment, such as gloves and eye protection, and disconnect the power before working on any electrical circuits. If you are not comfortable working with electrical equipment, leave the work to a qualified electrician. In addition to the steps outlined above, it is also important to consider the overall health of the pump. Regular maintenance, such as lubricating bearings, cleaning the pump housing, and inspecting the impeller, can help to prevent problems and extend the life of the pump. Keep a record of all maintenance activities so that you can track the pump's performance over time. This information can be helpful in identifying potential problems before they lead to a breakdown. By following these recommendations, it is possible to effectively troubleshoot submersible pump overload issues and ensure the reliable operation of the pump. Remember that safety is always the top priority when working with electrical equipment. If you are not sure how to proceed, consult with a qualified electrician. Considering the specific scenario of a 25 horsepower submersible pump operating at 460 volts, 3-phase, 60 Hz, with a full load amps rating of 34 amps, and experiencing thermal unit tripping after 40 minutes of runtime, the troubleshooting process becomes even more focused. First, revisit the voltage supply at the pump terminals. Use a multimeter to measure the voltage at the terminals while the pump is running. The voltage should be within plus or minus 10% of the rated voltage of 460 volts. If the voltage is significantly lower, investigate the cause of the voltage drop. This could be due to undersized wiring, loose connections, or a problem with the power source. Next, check the motor current with an ammeter. Measure the current on all 3 phases of the motor. The current should be balanced and within the motor's full load amps rating. In this case, the measurements of 30 amps, 31 amps, and 30 amps indicate that the current is relatively balanced and below the full load amps rating of 34 amps. However, it is still important to investigate why the thermal units are tripping. Since the current is below the full load amps rating, the problem may not be an overload condition. Instead, it could be related to other factors such as high ambient temperature or a problem with the thermal units themselves. Check the ambient temperature around the motor starter. If the temperature is high, it may be necessary to select thermal units with a lower tripping current. Also, inspect the thermal units for any signs of damage or wear. If the thermal units are old or have been subjected to repeated tripping, they may need to be replaced. Consider testing the motor insulation resistance with a megometer. This test can help to identify any insulation breakdown in the motor windings. If the insulation resistance is low, it indicates that the motor windings are damaged and the motor needs to be repaired or replaced. Also, verify the pump's operating conditions. Is the pump running continuously or is it cycling on and off frequently? If the pump is cycling on and off frequently, it may be necessary to adjust the control system or to install a larger pump. Also, check the pump's discharge pressure. If the discharge pressure is too high, it can overload the motor. Also, check the pump's suction conditions. If the pump is not receiving enough water, it can cavitate and overheat. If all of these factors have been checked and the problem persists, it may be necessary to consult with a qualified pump technician. They will have the expertise and equipment necessary to diagnose and repair the problem. Remember, it is always best to err on the side of caution when working with electrical equipment. If you are not sure how to proceed, consult with a qualified electrician. When dealing with submersible pumps, it is crucial to consider the environment in which they operate. Submersible pumps are often used in harsh conditions, such as in wells, pits, and sumps, where they are exposed to moisture, dirt, and debris. These conditions can accelerate the wear and tear on the pump and its components, which can lead to premature failure. Therefore, it is important to follow a regular maintenance schedule to ensure that the pump is operating properly and to prevent problems from developing. The maintenance schedule should include inspecting the pump for leaks, cleaning the pump housing, lubricating bearings, and checking the motor's electrical connections. It is also important to monitor the pump's performance, such as its flow rate and discharge pressure, to identify any changes that may indicate a problem. Another important consideration is the type of fluid that the pump is handling. Some fluids can be corrosive or abrasive, which can damage the pump's components. If the pump is handling a corrosive or abrasive fluid, it may be necessary to use a special type of pump that is designed for that application. It is also important to use the correct type of lubricant for the pump's bearings. Using the wrong type of lubricant can damage the bearings and lead to premature failure. Consult the pump manufacturer's literature for recommendations on the proper type of lubricant to use. In addition to the maintenance and operating considerations, it is also important to consider the safety aspects of submersible pumps. Submersible pumps are electrical devices that operate in wet environments, so it is important to take precautions to prevent electrical shock. Always disconnect the power before working on a submersible pump. Also, be sure to use a ground fault circuit interrupter to protect against electrical shock. Submersible pumps can also be heavy and difficult to handle. Use proper lifting techniques to avoid injury when moving or installing a submersible pump. By following these recommendations, it is possible to ensure the safe and reliable operation of submersible pumps. Remember, regular maintenance and careful operation are essential for preventing problems and extending the life of the pump. The fact that the pump runs for 40 minutes before tripping suggests a heat-related issue. This could be due to several factors, including inadequate cooling, a restricted impeller, or a problem with the motor windings. Inadequate cooling can occur if the pump is not submerged deep enough in the water. The water acts as a coolant for the motor, so it is important to ensure that the pump is fully submerged. A restricted impeller can also cause the motor to overheat. If the impeller is clogged with debris, it can restrict the flow of water and cause the motor to work harder. This can lead to increased current draw and overheating. A problem with the motor windings can also cause the motor to overheat. If the motor windings are damaged or shorted, they can generate excessive heat. This can lead to insulation breakdown and motor failure. In order to pinpoint the exact cause of the problem, it is necessary to perform a thorough inspection of the pump and its components. This inspection should include checking the pump's submergence depth, inspecting the impeller for obstructions, and testing the motor windings for insulation resistance. If the inspection reveals any problems, they should be addressed immediately to prevent further damage to the pump. It is also important to keep accurate records of the pump's operating conditions and maintenance activities. This information can be helpful in identifying potential problems before they lead to a breakdown. By following these recommendations, it is possible to troubleshoot and resolve submersible pump problems effectively. Remember, safety is always the top priority when working with electrical equipment. If you are not sure how to proceed, consult with a qualified electrician. Remember that electrical motors driving pumps are designed to operate within specific temperature ranges. Exceeding these temperature ranges can significantly reduce the motor's lifespan and lead to premature failure. The thermal units in the starter are designed to protect the motor from overheating by tripping the circuit when the motor current exceeds a predetermined level for a certain period. The selection of the correct thermal units is critical for ensuring that the motor is adequately protected. Oversizing the thermal units can allow the motor to overheat without tripping the circuit, which can lead to insulation breakdown and motor failure. Undersizing the thermal units can cause nuisance tripping, which can interrupt the pump's operation. The correct thermal unit size should be selected based on the motor's full load amps rating and service factor. It is also important to consider the ambient temperature when selecting thermal units. The thermal units are sensitive to temperature, and their tripping characteristics can vary depending on the ambient temperature. If the pump is located in a hot environment, it may be necessary to select thermal units with a lower tripping current to compensate for the higher ambient temperature. In addition to the thermal units, it is also important to consider other protective devices, such as fuses and circuit breakers. Fuses and circuit breakers are designed to protect the electrical system from short circuits and overloads. They should be sized appropriately to protect the motor and the wiring. It is also important to ensure that the motor starter is properly grounded. A good ground connection is essential for protecting the motor and the electrical system from faults. The ground connection should be checked regularly to ensure that it is secure and that there is no corrosion. By following these recommendations, it is possible to ensure the safe and reliable operation of submersible pumps. Remember, regular maintenance and careful operation are essential for preventing problems and extending the life of the pump. Another important aspect to consider is the type of electrical power being supplied to the pump. The pump is rated for 460 volts, 3-phase power. It is important to ensure that the voltage and phase balance are within the specified limits. Voltage imbalances can cause the motor to overheat and can lead to premature failure. Phase imbalances can also cause the motor to overheat and can lead to premature failure. It is also important to ensure that the power supply is stable and free from voltage fluctuations. Voltage fluctuations can cause the motor to operate erratically and can lead to premature failure. In addition to the electrical power supply, it is also important to consider the mechanical aspects of the pump. The pump should be properly aligned and secured to its base. Misalignment can cause excessive vibration and can lead to premature bearing failure. Loose mounting bolts can also cause vibration and can lead to premature bearing failure. It is also important to ensure that the pump is properly lubricated. The bearings should be lubricated regularly with the correct type of lubricant. Improper lubrication can lead to bearing failure and can damage the motor. In addition to the mechanical and electrical aspects, it is also important to consider the environmental conditions in which the pump is operating. The pump should be protected from moisture, dirt, and debris. Moisture can cause corrosion and can lead to electrical problems. Dirt and debris can clog the pump and can reduce its efficiency. It is also important to protect the pump from extreme temperatures. Extreme temperatures can damage the pump and can reduce its lifespan. By following these recommendations, it is possible to ensure the safe and reliable operation of submersible pumps. Remember, regular maintenance and careful operation are essential for preventing problems and extending the life of the pump. Finally, consider the overall system design. The pump is just one component of a larger system. The system should be designed to provide adequate water flow and pressure to meet the needs of the application. The system should also be designed to protect the pump from damage. For example, the system should include a check valve to prevent backflow and a strainer to prevent debris from entering the pump. The system should also be designed to provide adequate cooling for the pump. If the pump is operating in a confined space, it may be necessary to provide additional ventilation to prevent overheating. By following these recommendations, it is possible to ensure the safe and reliable operation of submersible pumps. Remember, regular maintenance and careful operation are essential for preventing problems and extending the life of the pump.